So hello everyone, I am back with another video. In the previous class we have solved the numerical related to the hosting system. In that particular hosting system till now we have solved this question. Let me we have solved this question, but one part I have left. That part is basically for the case 1, case 2 and the case 3, and the question here is maximum Derrick load, maximum equivalent load. So we have to calculate FDE for case 1, FDE for case 2, FDE for case 3. So these are the things we need to calculate. If you are following my lecture, we have already solved this derivation part. Do you remember, for case 1 the maximum equivalent load for case 1, that is En plus 4E plus 2 divided by Ne. This was the final output we have obtained in the case 1. If you do some calculation, you will get this derivation. If you haven't watched my previous video, go through that particular video, you will get it, right? So E is the efficiency. If you remember that in that case we have calculated a efficiency value, and that value I think is 0.841. I think and there is a number of lines are 8 number of lines in the question, right? 8 number of line is given. So 8 plus 4 multiply 0.841 plus 2 and divided by Ne, which is 8, and efficiency 0.841, multiply with the W, and W which is given in the question, that is 350 comma 000. If you solve this thing, you will get some value. Let me solve it. This will be equal to, for case 1 this will be equal to 0.841 multiply 8 plus 4 multiply 0.841 plus 2 divided by 8 multiply 0.841. you will get this much, multiply 3501230. so you will get maximum 2942 lbf. so you can do the calculation. If there is a calculation mistake, you can correct it, but this much amount of the value you are going to obtain for case 1. If you talk about the case 2, in the case 2 we have this FDE. If you remember, N plus 4 by N multiply with the W. This was the formula we have obtained. 8 number of line is there, 4, and there is a 8 multiply with the W. So if you try to solve this thing, 8 plus 4 divided by 8, bracket close, side also bracket close, multiply with the W is 3500123. so you will get FD, maximum equivalent Derrick load, which is 525 comma 000 lbf. so this is you will get the value in case 2. and if we talk about the case 3, maximum equivalent load for the case 3, the formula for the case 3 is, this is for case 3, right? The formula for the case 3 is Ne plus E plus 2 divided by Ne multiply with the W. Let me put the value. 8 is the number of lines, 0.841 plus 0.841 plus 2 plus N8 plus 0.841 multiply 350,000. This much amount of the value you are going to obtain, and this is the 8 multiply with a 0.841 plus 2 plus 0.841 divided by 8 multiply with the 0.841 completely multiply with a 350,121,300. So FDE case you will get for case 3 earlier was for the case 2 497,792.8 lbf. So this much amount of the value we are going to obtain. In the previous lecture we have solved all the criteria, all the finding 1 2 3 4 except this one, because I lost the formula at that particular time. That's why I am not able to recall it. Now I have recalled this formula and I have solved for you people, right? Let's move further. There is another very important question is here. That question basically saying that this question is related to diesel engine. A diesel engine is run to generate a power for the rig system. It given output torque. In this question torque is given. Torque is given, right? So let me write what are the data is given in the question. Torque, that is output torque is given, which is 1500 feet lbf. This the data is given. At an engine speed, n value is given, right? 14170 rpm. Considering that there is a friction loss in the pulley, so they are talking about E value, there is a losses is there, they are including the losses, and block and tackle system, right? Means when the block and tackle system moving upward and the friction caused between the rope, they are taking consideration, right? The hook load of a rig is W is given, means the total load is given 850,000 this lbf, pounds per feet. There are 10 lines, then n is equal to 10. Find the output power of the engine. So you have to find out output power. Velocity of fast line, so Vf we need to require, okay? Then the tension in the fast line, and tension in the fast line, that is nothing but the F we need to find, and the velocity of the traveling block, Vd we have to determine. Power output of a hook and block and system, we need to also calculate. Efficiency of the block and tackle system. This question is the blend of, if you remember that the power drive system I have talked about, as well as the hosting system. So this question is combination of these two things, power drive system as well as the hosting system, right? So yeah, so in this case, in this question torque is given, right? And torque is given, right? And we need to calculate the power. So we know that the power output, according to the formula previously we have learned, that the power is equal to, power is expressed into W, this is omega, into T. So omega is not given in the question. If you know that 2 pi n is the formula 2 pi value is here, n, if you put the value of n, where it is, okay, sorry for this thing, if you put the value of what you call pi and 2 pi n value is given, that is 1 7 1 7 1 0. This is the value. So if you solve this question, you will get the output value. That output, the value of omega, which is angular velocity, 735134 radian per minute. This is the output you are going to obtain after putting the value of n. So you have calculated the value of w. So what you need to torque is we have. So if you put the value of w as well as the torque value which is given in the question, you will obtain the output power, right? Power output you can easily determine. So yeah, let me erase this side. So if I am fast while solving the numerical, you can pause your video and you can write the data what I have already wrote. Okay, yeah, you people have a facility to pause the video, right? So yeah, P is w we have calculated 735,134, which is in the radian per minute, right? And in this case the torque is given, torque is multiplied by 1500 feet lbf. So this is the things which is mentioned in the question data, but we know that power can be calculated in the HP. So horsepower, 1 horsepower is equal to HP 1 HP is equal to 33,000, I think, am I right? 000 lbf per minute something, right? So if I want to convert this thing, so I have to simply divide to obtain the value in the horsepower, right? So yeah, this can be written as 1 horsepower is equal to 33,000. I am solving just basic thing, right? Which is equal to 1 feet lbf per minute, right? If you put all the value 3300 and which is equal to horsepower, right? Okay, so after solving this thing, you will get the power output. This everything will be cancelled out. You will left with the only in horsepower in the case of a horsepower, right? So don't worry about it. Like, yeah, 33415 you will get the horsepower. If you are not aware about this thing, you go and watch the power drive system, you will get it, right? Power output we have determined. Now we need to calculate the first line load. They are saying that, so first line load Fs is nothing but W by N, right? Fs is W by N. There is a, okay, this question, okay. So if you consider the case 1, right, if you consider the losses in the pulley, that is W by NE. And if you remember the value of N is equal to 10, in that particular case what will be the value of E? Just I need to write, because using the table I have to write that value, and that value, I don't remember that value. So yeah, in that case E value will be, if N is equal to 10, in that case E is equal to 0.10, right? So fast line load will be, W value is given, hook load 58000 divided by 10 multiplied by 0.81. if you solve it, that is 5801230 and 10 multiply 0.81. so you will get the fast line value, fast line 53654 lbf. so this is the another one of the important thing you have calculated. Now we need to calculate the velocity, right? Velocity, fast line velocity. So fast line velocity can be calculated, fast line velocity can be calculated, fast line velocity can be calculated, okay. Fast line velocity can be calculated using this fast line velocity F. If you remember that this power input is equal to Vf multiply the fast line load Ff. so if we want to calculate this thing, so in this case P input divided by Ff, this is the things we need to calculate. In this case power input, in this question given or not, we have to, yeah. So in this case, so we have just now calculated the power input, right? Why it is not writing, right? So in that particular case power input will be 3341.5 divided by Fs, that is 53654, and this is in the house power, so I have to convert this into the house power into the particular case. So I have to multiply with the 33000. so you will get the value, some value, that value is velocity of the fast line, you will get 9012. okay, let me calculate, because 334.15 multiply with the 331230 divided by 582. no, what is the value you have obtained? 53654. so you will get the value of Vf, you will get the 205.519 lb feet per minute. so this is the things you have gone through. Now the next thing is, next thing is, let me write somewhere here the value of fast Fs is 53654, right? so you will get the Vf value 205.519 feet per minute, and this is lbf, right? These are the data we have calculated till now. Now the next thing we need to find out the traveling velocity. so if you remember that I have derived the relationship between the when we are deriving the Vd is equal to Vf by n. if you remember that previous derivation, if you remember that, in that case, so Vf we have calculated 0.5510 divided by 10. So equal to answer divided by 10. So you will get the VD value 25. So what you are observing over here, the fast line velocity is more compared to the traveling velocity. What this is signify that the drum is rotating faster than the traveling speed, right? Next thing, we need to calculate the output power. So if we need to calculate the output power, in that case W multiply by VD will give, this is the unit in the feet per minute, right? So W is the hook load, and that hook load is given in the question 580,000 multiply with the 20.55, and I am just because I want to express this thing in the horsepower, so I am dividing 33,000. So if you try to do it some calculation, you will get some value 580,123 multiply 20.55 divided by 33123, right? So you will get the power output in case of 313181 HP, right? So power output we have determined. Next thing, what we need to find out the efficiency of block and tackle system. E is equal to, so E, if you remember that E is nothing but the P output by P input. So in that case, efficiency is equal to P output we have calculated, and P input value 3618 output by input value, maybe I don't remember exactly because I have erased the value. This will be 362.15 horsepower, and this is also HP. So E value you will get 0.99 something %. So everything is solved in this question. In the upcoming class, we are going to discuss about the one of the important topic called circulating system. Maybe in this numerical there are some calculation error, maybe there is chances of maybe calculation error, but the concept is same. Okay, thank you for watching this video.